Okay, here's question 1 on the free response part of the Chapter 7 test. So what we need to do here with the life insurance problem is just what we did when we did this problem a couple of times before earlier last week. First thing they ask us for is to copy this on your papers, so I'm presuming everybody can do that. The next thing they say is fill in the missing probability. Okay, well, you know, if the person, the 21-year-old male that buys the policy, if he doesn't die when he's 21, 22, 23, 24, or 25, he will die when he's 26 or older. So this probability has to be everything that's left over after you add all of these probabilities up. So figuring out what's left over, we find that this number right here has to be 0.99092. So now we've got the probability distribution. Now we've got to figure out what the profit or loss is. If the guy dies sometime in his 21st year, the insurance company has collected $300 for that year, but they're going to have to pay $100,000 out. So net, they're out $99,700. If he dies in the second year, they're going to be out the $100,000 and less two of the premiums, because they've received $600 now in the second year. So they're going to be out $99,400. And so this analysis continues, subtracting $300 or adding $300 every time. 98,800 and 98,500. If the guy dies when he's 26 or older, the insurance company's not going to pay anything because it was only a 5-year policy. That means the insurance company's going to get to keep the $1,500 they collected as part of the premiums for the 5 years of this policy. So that's how you figure out the profit or loss in each of the years. Calculate the mean profit. No problem. All we have to do here is just multiply down each of these columns to come up with the profit or loss due to somebody dying in that particular year. So I'm going to go ahead and pause this and I'll write it in and then start it back up again so you don't have to watch me compute. Okay, so here are the numbers as I multiplied them down, and I was going to run out of room, so I kind of tipped them up a little bit so you'll be able to see them all. This one right here, 1486.38, is this last column. Okay, to find the mean, all I have to do is add all of these numbers up. So adding all these numbers up, I get a mean of $585.65. Okay, now, you might think there has to be a quicker way to do this, and you would be right. You can use the calculator to do all of this. So what I'm going to do, if you give me just a second here, I'm going to go ahead and erase these numbers. Give you just a second to take a look at it just for a second longer. And then I'm going to go ahead and erase these like that. And I'm going to start up my calculator. So we'll give that a second to start up. And here we go. Okay. So here's our calculator. Now I'm going to put the calculator over on the other side. There, so we can see what we're doing. Okay, now, it's going to be quite useful to use lists. So I'm going to go ahead and go into the list editor, and I'm going to put the probabilities in first. And I believe it was 0.99092 was that last probability. Over in L2, I'm going to put the dollar amounts. So we had negative 99,700. I have to use the keyboard for this to get that negative. So negative 99,700, negative 99,400. Okay, and I'll go ahead and do the rest, and I'll pause it for a sec. Okay, so I have all the numbers in the calculator. To find the mean, all I need to do is multiply list 1 times list 2. And this then multiplies the probabilities times the random variable values, puts it in this table here. Now I should be able to sum up that table, L3, so second, list, math, sum, table L3, 586.66. And I think what I got before was 586, 50, either 56 or 65, I forgot what it was. So probably some round off error in there that happened as I was multiplying it out, because I wasn't using the TI calculator, I was using a little cheapo calculator. So now I know what the mean is, 586.66. I'm going to go ahead and just write this down in here so I have it, 586.66. Okay? Now we've got to do the standard deviation. That's going to be easy now that we have it all in the lists. All I need to do now is do the standard deviation formula, which I'm sure you all remember is the sum of the observation minus the mean squared times the probability. So xi minus mu times pi. And I can set that up very easily on the calculator. The xi's are in list 2, minus the mean 586.66 squared times the probabilities, and the probabilities are in L1. And I'm going to put a times in there, times L1. There. Do all of that, and it figured out all of those components of variance. All I've got to do now is add up L3 again, and I can do that. Second, enter will give you the last number, the last operation that you just did. So you can see sum of L3 here. This display's lagging a bit, so look at the big display. There's my variance. So I know the variance, there we go, variance is equal to, and let's go back to the calculator real quick, 9103.8585. So 9103.8585.44. And so standard deviation then is going to be the square root of that. So we'll just do the square root of answer, and we get 9541. So 9541.41. And that's in dollars, as is the mean. So that's how you do problem number 1. Fun stuff, huh?